Hello, year sevens. I hope that you're well and that you're in a quiet place away from all distractions and you have all your equipment with you. In today's lesson, we're going to use an analogy to explain how electrical circuits work. Our first task is to complete the retrieval practice questions. Please pause the video and attempt these now. So, our first question was, what is an electrical conductor? Electrical conductors are materials that allow the flow of electric charge. Give two examples of electrical conductors: copper, iron, any metal, and carbon graphite. These would be examples of electrical conductors. What is an insulator? Electrical insulators are materials that do not allow the flow of electric charge. Give two examples of electrical insulators. Plastic, rubber, or wood would be examples of electrical insulators. Draw a circuit diagram with a battery, open switch, which means it's off, two bulbs, and an ammeter in series in one loop or one path. So here we have the straight lines which represent our wires in a continuous loop. We've got our two bulbs down here. We've got an open switch. We've got our two cells, which gives us a battery. And we have our ammeter. Fantastic effort. If you've not done that already, green pen your work and draw the diagram. So, our success criteria in today's lesson is to use simple models to describe scientific ideas, to use a model to explain how electricity flows around a circuit, and to compare and contrast different models. So, what is a model? A model is one way in which scientists try to explain difficult concepts. They help scientists to think about an idea and explain it to others. However, some models are better than others. For example, how could a central heating system be used to represent a model of an electrical circuit? Well, in this model, we need to think about what could represent the current, the battery, the wires, and the bulb. Pause the video, pause the recording, and think about this now. So, there is a pump that pushes water around the system. The pump does a similar job to the battery in that it pushes the charges around the circuit. The bigger the push, the bigger the voltage. There are pipes that carry the flow of water. Instead of water, the wires carry the flow of charges around the circuit. This is the electric current. The bulb and the radiator are both very similar in that they use energy supplied by the circuit. Let's have a progress check. In the boiler model, what represents the current, the battery, the wires, and the bulb? I use this model to explain electric current in a circuit. Please pause the recording and do this now. So, The flow of water is represented by the current. The pump and boiler represents the battery. The pipes are represented by the wires, and the radiator is represented by the bulb. So the question states, use the model to explain electric current in a circuit. Current is the flow of charge around a circuit. The faster the charge flows, the higher the current. The current is the same everywhere in a series circuit. Current is not used up. Let's think now about the rope model. So imagine you were in the classroom. You'd be asked to stand up and push your stools under. You'd be asked to form a large circle around the edge of the room, and that you should have your palms facing upwards. I'd ask one of you to be nominated to become the bulb, and I'd place a rope in your hand. So I would have said to you, please hold the rope loosely, and I would pretend to be the battery. So I'd join the circle and pretend to be the battery. As the battery, I should pull the rope through the hands of the other students. That's my job. So it would look something like that. Now, in the rope model, have a think about what represents the current, what represents the battery, what represent the wires and the bulb, and if there is anything else that's going on. There might be a couple of other things that you think is happening in this model that you might want to actually comment on. So once you've done that, use this model to explain electric current in a circuit. Right. So the teacher was the cell. I hope you agreed. The student was the bulb or the component. The rope would be like the electrons or the charge. The speed at which we were pulling the rope is something new that we could have thought about but have not mentioned. Yeah, is actually the current or charge per unit per time. So there's an extension there if you thought about that. The speed at which the rope is being pulled, and perhaps any heat on our hands, that would be energy shifts to components. So those are two interesting and unique ideas that we haven't mentioned before. So does that mean you're now beginning to formulate in your head which model you would consider to be the better of the two? I hope you're thinking about that as we're going through this. So I force the rope that is already here to move in a loop. In the same way, a battery forces electrons that are already in the wire to move in a loop. The rope is obviously not coming from me, I'm just making it move around. The electrons are not coming from the battery, it's just making them move around. As soon as I start pushing this bit of rope, all the rope moves as all the rope particles are so close together. As soon as the battery starts pushing the electrons, all the electrons move as they are all so close together. The rope is never used up. The same amount of rope returns to me as leaves me. The electrons are therefore never used up. The same amount of electrons return to the battery as leave the battery. So this is one way to describe and understand Ohm's law, which you could look up and do some independent work on. We want to learn about the relationship between current, voltage, and resistance in a loop. And an additional independent task would be to think about which model you would consider to be the better of the two, the boiler model or the rope model. Fantastic listening, year 7s. Have a brilliant day.